Okay, see what had happened was, this is day 3 homework, some basic matrix operations. Okay, let's do this. So looking at problem number 1, we're going to multiply these two matrices together. Your thought process is this. Look at the dimensions. This is a 2 by 2 matrix. This is a 2 by 2 matrix. In order for this to be possible, the inner dimensions have to be the same. They are, so fine, it's possible. Now, once you know that they're possible, the next thing is to understand what the shape of your answer is going to be. And it's basically like this. It goes by the outer dimensions. So because the outer dimensions are 2 and 2, then I know when I multiply, I'm going to wind up getting a 2 by 2 matrix. So your next move should be to set up for yourself a 2 by 2 matrix, like answer. Okay, so I'm going to do that. So here comes a 2 by 2 matrix. I'm just going to use lines to organize. Okay, now here's how you find each individual part. Alright, this first element, alright, I could call it element 1, 1, because this element is in the first row and the first column. So if I want to find element 1, 1, then I have to do the first row times the first column. Okay, so I'm going to do that. So that would be 2, negative 1 times 4, negative 3. Alright, it's always row and then column. So that's going to give me 8 and positive 3, which is 11. Okay, so that's my first element. So that's 11. Alright, I'm going to come over to this element next. I could call this element 1, 2, because this is row 1, column 2. So if I want to find element 1, 2, I need to multiply row 1 times column 2. So I still have row 1 selected, but this time I need to look at column 2, like this. So row 1, again, is 2, negative 1. Column 2 is 4, negative 5. Multiplying gives me 8 and positive 5, which is 13. Alright, so that gives me element 1, 2. It's 13. Now I'm going to find this. This is the second row, first column. So this is element 2, 1. Now if I want to find element 2, 1, I need to do the second row times the first column. So I need to change both of these because I'm doing row 2, column 1. So this is row 2 times column 1. And that's going to look like this. Negative 6, 1. Alright, it's row 2 times column 1, which is 4, negative 3. If I multiply this out, I'm going to get negative 24 and a negative 3, right? So that's going to make negative 27. Okay, so that's what element 2, 1 is. Negative 27. And finally, if I want to find this element, I could call it element 2, 2, because this is row 2, column 2. And if I want to find element 2, 2, then I need to do row 2 times column 2. Well, there's row 2 already selected, and I need to do times column 2. So I'm going to do negative 6, 1, times 4, negative 5. Now that's going to give me negative 24, negative 5 So that's going to be negative 29. So that should be the final element. Alright, and that's it. So that makes this the answer to problem number 1. Okay, let's move on to problem number 2. Alright, man, I got 3 matrices to deal with. But we're going to follow the order of operations, sort of like you normally would. So you see these parentheses. That tells you that we need to add this first. Now, when you add 2 matrices, you just, you add the corresponding element. So look, this first matrix, we're not doing anything with it yet. So that's 2, 6, negative 6, 4. Nothing going on here. Times. Now, as I add these 2 matrices together, and I'm just going to put that right here, I'm just adding the corresponding entry. So 5 plus 1, that's 6. 3 plus 2 is 5. Negative 6 plus 2, that's negative 4. 2 plus 0 is 2. Okay, so I got this matrix by adding these 2. Now I can go back and multiply these matrices together, just like we talked about. Now, of course, this is a 2 by 2 matrix, and this is a 2 by 2 matrix. All right, because of the inner dimensions, 2 and 2, I know that this is possible. It's doable. Because of the outer matrices dimensions, I know that the answer is going to be a 2 by 2 matrix. So I like to go ahead and just set that up. So my answer is going to be a 2 by 2 matrix like this. All right. Now, the first element, all right, element 1, 1 would be this right here, row 1, column 1. Okay, element 1, 1, I need to do row 1 times column 1. So this is row 1, and this is column 1. So let's do that. So that's 2 and 6, and that's 6 and negative 4. If I put those together, I'm getting 12 and negative 24. I'm going to give myself more room, my friends. Whoa, took part of my problem with it. Oh well, I didn't really need that much. Alright, now I got lots of space. That's better. But Mr. Burton, I can't move mine down just right small. Now if I put these together, that's going to be negative 12. Okay, so that gives me my first element. So now, coming over here, this is going to be element 1, 2. Because this is row 1, column 2. So that means I have to do row 1 times column 2. Okay? Row 1, column 2. There's row 1, here's column 2. So here we go. That's going to be 2, 6. There's row 1. And this is going to be 5, 2. There's column 2. If I put these together, that's going to give me 10 and 12, which is 22. Alright, that tells me that this is 22. Alright, now I'm going to come down here, and this is going to be element 2, 1, because this is row 2, column 1. So I need to multiply row 2 and column 1. I'm going to have to change both of these. So now I'm looking at row 2 and column 1. Row 2, so that's negative 6, 4. Column 1, that's 6, negative 4. Put those together, that's negative 36 and negative 16. So that's negative 52. Alright, so this will be negative 52. That brings us to this element. Alright, so this will be element 2, 2, because this is the second row and the second column. Row 2, column 2. So I need to do row 2 times column 2. Okay, there we go. Row 2, column 2. So that's going to be negative 6 times 4 times 5 and 2. So that's negative 30 and 8. So that's going to be negative 22. Alright, so this is negative 22. And once again, we have our answer. So this should be the answer for problem number 2. Let's take a look at problem number 3. Alright, this is a 2 by 2 matrix and another 2 by 2 matrix. Because of the inner dimensions, I know that it's possible. These have to be the same. The outer dimensions, whoa. The outer dimensions tell me the shape of the answer. Alright, so I know that in the end I'm going to have a 2 by 2 matrix for an answer. So let's go ahead and set that up like you do. Alright, so I'm going to have a 2 by 2 answer. Alright. Let's start with this corner. This would be element 1, 1, because this is row 1, column 1. And speaking of row 1, column 1, we need to multiply row 1 times column 1. So that's going to be negative 1, 5, okay, row 1, and negative 3, negative 3, column 1. That's going to give me positive 3 and negative 15. Put them together, you get negative 12. So I have a negative 12 right there. Now let's move over to this one. This is going to be element 1, 2, because this is row 1, column 2. So that means I need to multiply row 1 times column 2. So there's row 1, and here is column 2. So row 1, that's negative 1, 5. Column 2 is that 6, 0. If I multiply, I get negative 6 and 0. Put them together, that's negative 6. So that tells me I have a negative 6 right there. Now moving down to this corner, that's going to be element 2, 1. Alright, because this is row 2, column 1. So with that in mind, I need to do row 2 times column 1. So here's row 2, and here is column 1. So row 2, that's 5, negative 5. Column 1 is negative 3, negative 3. That gives me negative 15 and 15, whoa, and positive 15. Together that makes 0. So I'm going to have a 0 term. Last, I'm going to do this position, and this is going to be element 2, 2, because this is the second row and the second column. So I need to multiply the second row times the second column. So here we go. The second row is our 5, negative 5. Second column, 6, 0. So that's going to be 30 and 0, which is 30. So that's going to be 30. Alrighty then. That's it. That's the answer number 3. Put a bow on it. All right, let's move on and talk about number 4. Now, looking at these dimensions, I have a distinct fear that this is not going to be possible. So let's just work through the dimensions without actually doing any other work yet. Look, first thing we would do is our multiplication, all right? Just like, PEMDAS, please excuse my dear Aunt Sally. First you do your parentheses, your exponents, then you multiply or divide, add or subtract. So we're going to definitely do our multiplication before we do this addition, all right, order of operations. So we would do this. But with that in mind, get my space back. The dimensions here are 2 by 2. The dimensions on this little guy are 2 by 1. Would this multiplication even be possible? Yes, it would be possible because of the inner dimensions are these 2's, and they match, so it's possible. Now, what would be the dimensions of the answer? All right, the dimensions of the product would come from these. Okay, so the product here would be a 2 by 1 matrix. So fine, we have this 2 by 1 matrix. But in the meantime, this matrix right here is a 4 by 1 matrix. So we have a 2 by 1 and then a 4 by 1. And so our next move, now this is addition, okay? So next we're supposed to add. Can you add a 2 by 1 matrix and a 4 by 1 matrix? The answer is no, you cannot. In order to add, the dimensions have to be exactly the same. You can add a 2 by 1 and a 2 by 1. You can add a 4 by 1 and a 4 by 1. But you cannot add a 2 by 1 with a 4 by 1. So this is going to be not possible. Or you can say undefined. Either way. Alright, so we're done with number 4. Alright, let's deal with number 5. Alright, we are adding, and when you're adding, you are just adding corresponding terms. So the resulting matrix is going to have the same dimensions. -2 plus -4 is -6. -3 plus 6 is +3. -6 plus 0 is -6. And 2 plus -3 is -1. So that's it for number 5. We added and we're done. Alright. Kind of easy. What about number 6? Okay, here's number 6. Let's see, let me leave myself a little more room. Okay, again, let's follow the order of operations, and let's go ahead and do what's inside of the parentheses first. So we'll save this -4 scalar multiplication for last. So as we multiply these, like we've seen many times in this assignment, this is a 2 by 2, this is a 2 by 2. It's possible because these match, so I know it's possible. Because of the outer dimensions, then I know that my answer is going to be a 2 by 2 answer. Okay, so let's just set that up. So in my next level, I'm still going to have my -4 there. But that -4 is going to be multiplied by a 2 by 2 matrix. Okay? So we're going to go through and find everything. So this first one is our element 1, 1. Okay, so that's going to be row 1, which is -3, -6, times column 1, which is -2, -1. That's going to give us 6 and 6, which is 12. Alright, now we move over here. this will be element 1, 2, because we need row 1, which is -3, -6. Okay, that's row 1. And now we need column 2, which is 6 and -4. That gives us -18 and +24. And that gives us 6. So that's going to be a 6. Next we move down here. Alright, so I'm going to call this one element 2, 1, because this is row 2, column 1. So I need to do row 2, 1, 4, times column 1, which is -2, -1. So that's -2 and -4, which makes -6. So there's our -6. Last, I'm going to need element 2, 2, because this is row 2, column 2. So I need row 2, which is 1, 4, times column 2, which is 6, -4. That's going to give me 6 and -16, which is -10. So this will be -10. Alright, so we've got this so far. Now we can go ahead and get the final answer by multiplying all of these by -4. Alright, and that is called scalar multiplication. Okay, so this is going to be, -4 times 12 is -48. -4 times 6 is -24. -4 times -6 is +24. And -4 times -10 is +40. So this should be the final answer for number 6. Now it's time for number 7. Alright, continuing using the order of operations. Alright, we're going to do our multiplication before we do the addition. Okay? So save this addition business for later. First, we're going to do this, this right here. Alright, now let's see if it's even possible. This is a 2 by 2 matrix. And this is a 2 by 3 matrix. Is it possible? Yes, it's possible, because the inner dimensions are the same, 2 and 2. Alright, fine, it's possible. What will be the shape of the answer? What will be the dimensions of the product? Well, the product dimensions will come from the outer dimensions. So our answer will have the shape 2 by 3. Alright, so let's just get set up and ready for it. Okay, so basically we're saying we're just going to bring this matrix down. Alright, so we're just going to have 3, 0, 1, 5, 3, -3, plus. Okay, and then we're going to have some sort of a 2 by 3 matrix. Alright, so that's going to be like this. 2 rows, 3 columns. So we just need to find out what this matrix is and then add. So we're going to do what we've done many, many, many times now. Alright, let's start with this element right here. This would be element 1, 1. Okay, element 1, 1. So I'm looking for row 1 times column 1. Okay, now, so row 1 is this, -1 and 3. Okay, column 1 is 0, 1. So that gives me 0 and 3, which is 3. So that tells me I have a 3. Now I'm going to move on over and do element 1, 2. Because I'm still in row 1, but this is now column 2. So I need row 1 times column 2. So row 1 is still going to be negative 1, 3. But now column 2 is this negative 6, 1, column 2. That's going to give me 6 and 3, which is 9. So that's going to be 9. Now I'm going to move over to here. This is still row 1, but now I'm in column 3, element 1, 3. So I need the first row times the third column. The first row is still negative 1, 3. Now the third column is negative 1, 4. So that's going to give me 1 and 12, which is 13. Okay, so that is what I have so far. Let's keep going. Next, I'm here. This is going to be element 2, 1, because this is in the second row. So that's 6, 1 is the second row. And it is in the first column. First column is 0, 1. That's going to give me 0 and 1, which is 1. Let's move to here. This is going to be element 2, 2, because this is row 2, column 2. So I need row 2, which is 6, 1, times column 2, which is negative 6, 1. That's going to give me negative 36 and 1, which is negative 35. Alright, so one more element to do. Is there space down here? Okay. Fine. The last element is element 2, 3, because this is row 2, column 3. So I need row 2. Okay. Row 2 is still 6, 1. Column 3 is negative 1, 4. So that gives me negative 6 and 4, which is negative 2. Alright, now that is not the final answer. That's just what you get by multiplying these two matrices together. To get the final answer, I need to now go ahead and actually add these together. So if I do that, I'm going to have, 3 plus 3, so that's 6. 1 plus 9, that's 10. 3 and 13, that's 16. 0 and 1 is 1. 5 and negative 35 is negative 30. And negative 3 plus negative 2 is negative 5. So this will be the final answer. Okay. Alright, last one. Again, I see parentheses, so I'm going to do what's inside the parentheses first. So I'm going to keep this negative 5 for a little while. Okay. Now, adding what we have inside here, 2 plus 2, so I got a 4. Negative 1 and negative 4 make negative 5. Negative 6 and 4 make negative 2. Alright, I guess I don't need the parentheses. What I more need are brackets. Alright, so fine, I added them. And then to get the final answer, I would go ahead and do the scalar multiplication. Multiply everything by negative 5. So that is going to give me negative 20, 25, and 10. And that would be the answer to number 8, which I believe is the end of this lesson. All right, so that wasn't too bad. I will see you on the next video.